June 2022. Further maths mechanics. Number 3. The function y of x satisfies the differential equation dy dx equals to f of xy, where f of xy is equals to 2 plus y over x and y of 1 is equals to 1. dy dx equals to f of xy and the f of xy equals 2 plus y over x. It means that dy dx is also equals to 2 plus y on x. Y of 1 is equals to 1. It means that when y equals to 1, x is equals to 1. Since from the question it is said y depends on x, that is y is a function of x. Let's say y equals to 1 is a value of y at y naught and x equals to 1 is a value of x at x naught. That means y naught is equals to 1 and x naught is equals to 1. That means the value of dy dx at naught will be equals to 2 plus y naught all over x naught. Roman 1. Use the formula yr plus 1 approximately equals to yr plus h f of xy with h equals to 0.05. You know, f of xy is the same like dy dx. That means yr plus 1 can also be written as yr plus h dy dx. I'm supposed to use this formula to obtain the value of y of 1.1, giving the answer correct to 3 decimal places. Y of 1.1 means when x equals to 1.1, y is equals to what? To obtain the value of y when x equals to 1.1, we need to carry several steps of approximations up to the value of x equals to 1.1. The value of x at each step of approximation is obtained using the formula xr plus 1 is equals to xr plus h. That is, when r equals to 0, we have x0 plus 1, that's in the place of r I put 0, is equals to x0 plus h. That 0 plus 1 is 1, x1 is equals to x0 plus h. Step 1. This step is when r is equals to 0. That is, this equation becomes y naught plus 1 is approximately equals to y naught plus h times dy dx naught. 0 plus 1 is the same like 1, so it means y naught plus 1 is y1. It's approximately equals to y naught plus h into 2 plus y naught all over x naught. Since dy dx naught is 2 plus y naught all over x naught, that means y1 is approximately equals to y naught, which is 1 plus 0.05 times 2 plus y naught, which is 1 all over x naught, which is also 1. That means y1 can be simplified as 1 plus 0.05 times 3. 0.05 times 3 is 0.15. That's 1 plus 0.15, which is also approximately equals to 1 plus 0.15, which is 1.15. From the formula xr plus 1 equals to xr plus h, which is the formula to obtain the value of x at each step. It means at r equals to 0, x0 plus 1 is equals to x0 plus h. That is, x1 is equals to x0 plus h, which is 0.05. That means x1 is equals to 1 plus 0.05, which means x1 is equals to 1.05, which is 1 plus 0.05. So we can conclude that at r equals to 0, y1 equals to 1.15 when x1 equals to 1.05. From here, we need to still continue to step 2, since the target is to get the value of y when x equals to 1.1 as required by the question. Step 2 is when r equals to 1. Using this formula, it means at r equals to 1, we'll have y1 plus 1 is approximately equals to y1 plus h dy dx at 1. That's at r equals to 1. That means y2 is approximately equals to y1 plus h into 2 plus y1 all over x1. Since dy dx at 1 is when the value of y is y1 and the value of x is x1. That means y2 is approximately equals to y1, which is 1.15 plus 0.05 into 2 plus 1.15 all over x1, which is equals to 1.05. That means y2 is approximately equals to 1.15 divided by 1.05 plus 2 times 0.05 plus 1.15, which is equals to 1.304. That means y2 is equals to 1.304 when x2 is equals to x1 plus h. That is x2 is equals to 1.05 plus 0.05. That means x2 is equals to x1, which is 1.05 plus h, which is 0.05. 1.05 plus 0.05 is 1.1. That means y2 is equals to 1.304 when x is equals to 1.1. That means the value of y when x equals 1.1 is equals to 1.304. Roman 2. Use Simpson's rule to estimate the value of the integral from 1 to 1.1 y dx. Simpson's rule is a technique of approximation which helps us to approximate the area under a curve. Let's say f of x is a continuous function in the interval a to b. The area under the curve of f of x can be estimated using the Simpson's rule formula, which is given by the integration from a to b f of x dx, which is equals to h on 3 first plus last term plus 4 times odd terms plus 2 times even terms. H in the formula is the step length, which is given in the question as h equals to 0.05. The first term is the value of y naught corresponding to the value of x naught, and the last term is the last value of y corresponding to the last value of x. From Roman 1, we can tabulate the values as follows. That is, on the table we have xr, yr, where xr and yr are the values of x and y at different values of r. At x naught, xr is 1. At y naught, yr is 1. At x1, xr is 1.05 and y1 is 1.15. x2 is 1.1 and y2 is 1.304. Now the integral from 1 to 1.1 of y dx is equals to h, which is 0.05, into the first term of y, which is 1, plus the last term, which is 1.304, plus 4 times the odd terms. The odd term here is y1, which is 1.15, plus 2 times the even terms. But here there are no even terms between the first and the last term. So the only term we have between the first and the last is the odd term. We call this term the odd term because the subscript of y, which is 1, is odd. Now this is equals to 1.1.04 plus 4 times 1.15, which is 6.904 times 0.05 all over 3, which is equals to 0.115 in 3 decimal places.